In this example, we are given the input signal xn and also the frequency response hj omega, and we are asked to find the output yn. Now, we know that the output can be written in terms of Fourier series as follows. Yn equals summation of bk e to the power of jk omega 0n. Bk is the Fourier coefficients of output. So, in order to compute the output, we need to find bk and omega 0. On the other hand, we know that bk equals ak times h of jk omega 0. So first we need to compute ak and omega 0. For signals of the form e to the power of j omega n, sine of omega n, cosine of omega n, the period is related to omega. We know that omega 0 equals 2p divided by n, and also n equals 2p divided by omega times m. So if we find omega, we can compute the period n. Now, if you look carefully in this example, omega equals 3p over 8. So, n equals 2p divided by 3p over 8, which gives n equals 16 over 3. Now, the smallest integer multiple that makes this value an integer is when m equals 3. So the fundamental period becomes n equals 16. Therefore, omega 0 equals 2p divided by 16, which is p over 8. Now, to solve the problem, we need to express xn in Fourier series form. Now we rewrite the signal. The constant term 1 can be written as e to the power of j times 0 times p over 8 times n. Now for the sine term, using Euler formula, we know sine theta equals 1 over 2j times e to the power of j theta minus 1 over 2j times e to the power of minus j theta. So we can write now we compare with the standard Fourier form. For the constant term, k equals 0 and a0 equals 1. For the positive exponential, k equals 3 and a3 equals 1 over 2j e to the power of j p over 4. And for the negative exponential, k equals minus 3 and a minus 3 equals minus 1 over 2 j e to the power of minus j p over 4. Now we compute bk. For k equals 0, b0 equals a0 times h of j0. From the frequency response, This is 0. So B0 equals 0. For k equals 3, B3 equals A3 times h of j 3p over 8. From the graph, this equals 1. So B3 equals A3. Similarly, for k equals minus 3, b minus 3 equals a minus 3. Now we can write the output yn equals b minus 3 e to the power of minus j3p over 8 n plus b3 e to the power of j3p over 8 n. With substituting values, yn can be written as follows. Using Euler formula, this simplifies to yn equals sine of 3p over 8n plus p over 4. So if you compare the output with the input, you can see that the constant term has been removed. The sine term has passed through the system. So the system behaves like a filter. It blocks the DC components, frequency 0, and it allows the sine component to pass. Problems like this are also available on this channel. If you find them useful, feel free to follow the channel.